Good day. So today we are going to continue from where we left off from our previous lesson on parabolas. So we are going to start with a question which is going to tackle the concept we covered in the last video. So the parabola x squared plus 3x minus 6. And we are asked to find the following information about the parabola. We have first the direction it opens. Now, if you would remember, we said the direction that it opens can be either downwards or upwards. Okay. And so for this, since a or the coefficient of x squared for the parabola is positive or is greater than 0, it means the graph would open upward, something like this. So upward, a graph will open upward. And then on which side of the y-axis the vertex of the parabola will lie. So this is the vertex. So we want to know on what side of the y-axis will the this vertex lie. And we know that is related to the product AB, okay, of the quadratic equation, the quadratic expression. So here we know the product AB is, A is 1, B is 3. So 3 times 1 giving us 3, which is positive. Since the sign of AB is positive, then it means that the sign of the x coordinates of the vertex would be negative. Okay, means the sign of the x coordinate of the vertex would be negative. And because of that, it means that this vertex will lie on the negative side of the y-axis. So if this is our y-axis, if this is our y-axis, then this is going to lie. Let's say this is our x-axis, okay. Then our curve is going to lie like this on the negative side. So that is it. And then with the last part, we have to find the y-intercept, which is the easiest. The y-intercept is c, which is negative 6. So that is it for this question. Now, today we are going to talk about how to, when you have an equation of a parabola in the of a curve in the factor or the factored form, and then each of the factors are raised to either odd or even degrees. What information we can get from that regarding the curve? Okay, so let's talk about that now. Let's say you have x minus 3, okay, as one factor, That's x minus 3, x minus 3, so let's say x minus 3 is a factor. Then you have another factor to be x minus 2. Okay, minus what? 2. 2 here. Do something like this. Okay. Depending on the power of these factors. You see, this is a is let me add another one. That's, let's say, x minus no, x plus 3. Let's do it x plus 3. Okay. Let's say you have this. Let's say you have this. Depending on the power of these um factors, you can tell how the graph of the parabola would move on the Cartesian plane. Okay. So here it means you have something like this. So let's say if this is our Cartesian plane, this is our Cartesian plane here. Okay, this is our Cartesian plane here. Yes, so this is it. So 3, so you have -3. So let's say you have -3 here, -3 here. You have -2. You have 2 here. So -3, 2, and 3. Okay. Sorry, here is supposed to be plus. Okay, plus. So you have this. Now, let's say the power of x cubed is 1. Okay. And the power of x squared, the power of x minus 3 minus 2 is 2. And that of x um plus 3 on plus 3 is 3. Okay. Now, if the curve starts like this, okay, and goes this way, then because the power of x minus 2 here is squared, then it means that, sorry, let's make this cubed instead. Okay. And then make this 1. Okay, this 1. So this, the roots here will be what? 3, 2, and what? And then -3. Now you know the roots are the x-intercepts of the curve. So these are the roots here, -3, 2, 3 again. So so you are starting with -3 here. So it passes through -3 as the first intercept. Now and goes like this. Now, because the x minus 2 here has an even power, which is 2, then it means that this curve coming here is going to bounce back here. And it's not going to cross. So whenever you have an even power, then your curve isn't going to pass through your intercept. It is going to get to the intercept and bounce back. I hope I'm clear with that. And now it is going to come here again. Now, this time, since x minus 3 here has a odd power, then it is not going to bounce back, but it's going to pass through. Okay. So the take home from this concept is that whenever you have an equation of parabola in the factored form, you check the degrees of each of the factors, and that should give you an idea of the nature of the curve. So whenever the factor has an even root, then it means whenever the factor has an even power, it means that on the Cartesian plane, whenever you are drawing the graph and it gets to that point, it's going to bounce back. Or when it has an odd root, it is going to pass through that particular intercept. I hope that's clear. Now let's solve this example. Okay. Now, the graph of the function f is shown in the xy plane above, where y is equal to y equals fx. Which of following functions could define f? So this is our f here. So we want to use this to answer this. So first of all, we have -1 here. That should tell us that your factor is what? X minus 1. Sorry, x plus 1. That's our factor. That's our first factor. That's what we have to do first. Then you have x. I have 1 here, which means x minus 1 is also a factor. So x minus 1 is also a factor. Then you have 3 here. So x minus 3 is also a factor. So x minus 3 is also a factor. Now, we are almost there with our answer. So now we have our factors. Okay. Now let's check which of the possible answers have our factors. X plus 1, x minus. So x minus x plus 3 is not here. So this is wrong. Right away, this is wrong. X plus 3 is not also here. So right away, this is also wrong. Now, x minus 3 is here. X minus 1 is here. X plus 1 is here. So this is a probable answer. This is also x minus 3, x minus 1, x minus 3. So we've been able to eliminate with just the first step. We have C or D as our possible answers. So now, how then do we get our final answer? Now, we said whenever you have an even root, you bounce back. Whenever you have an odd root, you pass through. Now, here, we can see that the graph is passing through -1. Since it's passing through -1, then this should have an odd root. Sorry, an odd power. Okay. So your x plus 1 should have an odd power. Now let's check whether x plus 1, which of them has x plus 1 with an odd power. Right. You see x plus 1 here with an odd power for d and an even power here. So it means our d is the answer. You don't have to go further to know that d is your answer. Now, I hope this is very clear. If this was to be the answer, as our graph moves here, it wouldn't have passed through. It was supposed to have bounced back like this and went. You get it? So, since it passed through, it means it's an odd and not an even power. So, D is our answer. Now, I hope these two concepts are clear. So, we've tackled this, we've tackled that. Now, let's move to our next, which is the vertex form. Now, the vertex form is usually in this form, A, where usually this A is the coefficient of x squared in the standard form. Then you have x minus h and k, where h, comma k, where h, comma k is your vertex. So with the vertex form, you can directly get the vertex from it, okay? And in this case, h, comma k is our vertex. So k here is the maximum value of the parabola, maximum value for y. And then h here is the maximum value for x. So let's say you have the equation of a parabola being 2 multiplying x minus 3, okay, all squared plus 4. Then from this, we know that the vertex is 3, 4, okay, 3, 4. So when you ask the maximum value of the function of the parabola, we say is what? And this particular one will be minimum because of the coefficients of 2. We see the minimum value is what? 4. And the minimum value for x would be what? 3. Or the value for x for which the function has minimum value is 3. So that's it for that also. So we've tackled this. Now, there is a way in which you can get you can convert your vertex form into the standard form directly. So you might be given questions where you would have to convert this form directly into this form. That's into the form ax squared minus, I'm sorry, plus bx plus c. Oh, sorry. This is supposed to be factored form. Now, the standard form is not easy to get from the vertex form. You just expand everything and you simplify. It's the factored form which is a problem. Okay, the factored form. Now, how do you convert this into your factored form? You know your factored form is made up of what? The factors of the, or the, yes, the factors of the parabola. Okay, now, this is how you do it. So it's usually in the form A, where A is here, multiplying the factors. So let's work with this vertex form of this parabola. So here, so our answer, so converting this to the factored form, you'd have 2. Okay. Now then you'd, to get the factors, it means you have to find the roots. So what you do is to find the roots. And it's easy to find the roots from here. I know if this can be factored, the roots, it has real roots, but let's try. So here you have um this, so 2 multiplying x minus 3, okay, squared equal to 0. So we move 4 to the other side, making it -4. So I think if it's 4, it will be difficult to solve. So let's make it 8. Let me see if it will work. Let's make it 11. Let's make it -11. Okay, sorry. So let's make it -11. So if it's -11, it becomes 11 here. Now, if it's 11 here, 11 2 won't work. So let's make it minus uh, 8. Okay, let's make it 8. So in this case, you have it crosses to become 8 here. Now 2 comes here to cancel it, making it 4. Find square root of both sides. So x minus 3 will now be equal to plus or minus 4. So then our roots would be x will be equal to either 3 plus 4, which is 7, or 3 minus 4, which is -1. Okay, so our answers are 7 or -1. So the factors would be what? X -7 and what? X plus 1. X plus 1. So this is the factored form of this parabola. So first of all, what do? You find the roots. So how do you find the roots? Using normal algebra. You move the constant term to the other side. You divide by the a here, and then you find your x. After finding your x, you just convert them into your factors, and then you multiply by your a here. You multiply by your a, and then you are done. Now, the last thing we would want to cover in this video is to talk about how to obtain your vertex, okay, your vertex from the standard form. Now, this is the standard form. You might be asked questions where you'd be asked to find the vertex of the parabola directly from your standard form. You won't be told to do it directly, but then to save time, doing it directly from the standard form would help instead of you converting your vertex form to the standard form before you converting your standard form to the vertex form before finding the vertex. That would be a long procedure. So it is best to get it directly from here, which is very simple for us to do. So let's say your vertex is given by HK, okay, HK. Now, your H here, which is the x coordinate of the vertex, would be the sum of your roots here over 2, okay, from the standard form. So H, okay, is equal to B, B over A. No, B over 2, sorry. That's the average of the sum of the roots of the parabola. So B over 2 would be your H. And now to find K, you just input B over 2 here to get your K. Okay, you input your B over 2 here. So let's take an example. Let's use this parabola here. We want to find the vertex of this parabola. Okay. Now, looking at the parabola, you know that the x-coordinate of the vertex should be 3 over 2 because the sum of roots is what? 3. And so your vertex should be 3 over 2. And then to find your k, you just put 3 over 2 here. So 3 over 2 squared will be 9 over 4. And 9 over 4 plus, okay, plus 9 over 2. That's 3 times 3 over 2. And plus, then minus 6. Okay. Now you can convert this to 18 over 4. And so you'd have 9 plus 18, that's 27 over 4. 27 over 4. Now you have 27 over 4 minus what? 6. That would be what? 27 minus 26. This will be equal to 27 minus 26. That's 4, 6. Sorry, minus 24. That's 4 times the 6. 24 all over 4. So this is giving us what? 3 over 4. So it means the vertex of this, it means the vertex of this parabola is what? 3 over 2, 3 over 4. And then you are done. Very simple. Now let's use completing of the square to convert this to the vertex form. Use it to find the vertex and confirm whether this we did here was right or wrong. So here, to convert this to vertex form, you know you have what? X plus 3 over 2. Okay. 3 over 2 squared. Okay. Now from here, we know that our x-coordinate of the vertex should be minus 3 over 2. But here we had 3 over 2. So it means there's a problem with this solution. And let's go back and check what we did wrong and correct our mistakes. So we said the x-coordinate of the vertex should be the average of the sum of the roots. Now this is the sum of the roots. Okay, this The mistake we did was that the 3 here is not the sum of the roots, but rather negative of the sum of the roots. Okay, so it means our sum of the roots will be minus 3, minus 3. And then usually if there was something here, it means we would have divided it by the 3 before we get the sum. But since here is 1, our sum will be negative 3 over 2. Sorry for the mistake. So negative 3 over 2. Then you now put negative 3 over 2 here to get that for the y coordinate, meaning our 3 over 4 will be wrong. So let's just use the vertex. Let's complete this, and then after that, we'll see if it will match with when we put this into this equation. So x plus 3 over 2 squared. Then you have what? Minus what? 3. I don't think we've covered conversion of factor this into the vertex form. I think we would treat that later. So 3 over 2 all squared, then minus 6. Okay, minus 6. Now, we know this would be minus 9 over 4. Okay, minus 9 over 4 minus 6. Okay. Simplifying this, you have negative 9 minus 24 all over 4. So that's negative 9 minus 24 is negative 33. And negative 33 then over 4. Okay. So it means when we input this value here into this equation, we should get minus 34, which is obviously the y coordinate of the vertex. So let's put this here to confirm that our answer is correct. So minus 32 here would be what? Sorry, minus 3 over 2 here would be 9 over 4. So we have 9 over 4. And putting it into plus 3x would be what? Minus 9 over 2. Minus 9 over 2. Then putting it into minus 6. Sorry. So we have minus 6 here. So now let's simplify. You have 9, 18 minus 36. To make it easier, let's convert this to 18 and the denominator to 4. So now you have 9 minus 18, which is minus 9. So you have minus 9 over 4 all over minus 6. Sorry, all over 4. 4 and minus 6. Now remember that's what we had for here before we simplify to minus 3 over 4. So it means that our answer here is right. So we did a mistake at first, which are mistakes we should try and prevent during the start. We just took the 3 here and divided by 2. We're supposed to take the negative of the 3 here. So this should tell us that when you take the standard form and you want to find the x coordinates of the vertex from the standard form directly, it will be negative what? B. That's from the standard form, negative b over 2. But then that's when your coefficients of x squared is 1. If you have a coefficient of x squared to be a value, let's say a, then you have a here. Okay, it will be negative b over 2a. And then that's for the y coordinates of the vertex will be negative b over 2a plugged into the standard form. And that will be here. So that should be it for this video. See you next time.